Okay, so previously we actually discussed about the aliasing issues and the problems that we don't know. Alright, and then now we're going to talk about the why do we use low pass filter. Alright, and in the end, why low pass filter is not that good after all. Okay, it's good, but to a certain extent, is to a certain application is not good. Anyway, so in the RT domain or the analog domain, you have this spectrum over here, for example. Alright, however, in the R*S domain, you have so many spectrum all the way to go to infinity, right? All the way go to infinity. So normally we would want this thing over here, this middle part of this thing over here, to be only because we're only interested in the middle part, right? We are not interested in the subsequent stuffs, right? Because the subsequent stuffs is talk about more frequency, because this is the frequency line, this is the amplitude of your whatever signal. Alright, so over here you wouldn't want any frequency that is larger than your whatever frequency that you want. Alright, so what we can do, we can use the low pass filter. Alright, a low pass filter is this is the whatever spectrum, and you have a low pass filter over here. I think this is the frequency lah, yeah, this is the amplitude. So over here at low frequency, you allow the signal to pass through, and then after that at certain cutoff frequency, which is your sampling frequency, I think, and then you'll just zoom, go down. Alright, I think this should be the sampling frequency that you want to put in. Alright, so you put in your sampling frequency, you only take in the sampling frequency of whatever signal that you have. Alright, I think I mean, so I repeat again, this I may be wrong, but I think that this is the sampling frequency. Okay, because over here this is your sampling frequency, so you're gonna take whatever information of your sampling frequency of your whatever thing that you want. Okay, all the rest we are not interested at all, right? Because we are not interested of other signals that is coming from other stuff. I think it should be over here lah, this thing over here, because this is analog, this is digital. But anyway, hope you get what I mean. So therefore, in this case of that happens, the low pass filter somewhat filter off the red color one. Alright, so instead of the red colors one or like this, alright, so you actually filtered it off. So they are somewhat going to be lower and lower and lower. Okay, or nonetheless you can also utilize your low pass filter. I forget where I stopped, but anyway we will have only this thing, or the rest is somewhat going down to be negligible. Okay, alright, this particular information can be tapped into over from here. Anywhere, yeah, and this is the point where I don't know whether am I correct. This is the thing, alright, which I've shown you. However, if you talk about this thing over here, your low pass filter can actually prevent, you see over here they have some cutting. Right, at first your signal may be something like this, right? And then after that you actually, because of the overlapping over here, alright, you somewhat put it straight line for this thing. Alright, this thing over here, how should I say initially your signal is something like this, right? It's spread out very evenly. Alright, so we don't want this part over here to interact with other parts, right? Over here, this is the point where they alliance. Alright, so therefore what we can do is to actually use the low pass to actually bring this thing to slightly like this. Okay, so this is another explanation for the low pass filter. Alright, you see, because over here, this thing over here, yes, it helps in the aliasing issue, but it does not help me to explain this thing. It all goes down. So this raises another question, that is this particular spectrum over here, alright, the same spectrum as this one. Alright, if it's not the same, then what is all this all about, and things like that. Alright, but at the end, the take home that you can take home, I don't know what I'm talking, but the low pass filter can actually help in aliasing. Alright, so you can help in aliasing. However, this is the problems that comes in. Alright, the aliasing part helps you to make your signal to prevent aliasing, but you cannot, maybe I should write it down first, you cannot shift your signal. Okay, you cannot shift your signal. So I repeat again, your low pass filter can help in prevent the aliasing. Alright, why do we use low pass filter to prevent aliasing? Okay, it's because if happen that you cannot meet the requirements that your omega sampling frequency, alright, is equals to your 2 times original frequency. Then if that's the case that happens, alright, your sample frequency, if you cannot meet, what you can do is to input a low pass filter. So that because of some constraints or whatever, so therefore we put a low pass filter to do these things. But and you may wonder why do we cannot shift the signal? Okay, to a more definition way of saying, alright, the shifting of this signal would cause phase shifting. Alright, if you should remember your Nyquist plot, you have a gain margin and your phase margin. Alright, your phase margin is the angle towards the -1. Alright, this is the angle. So if you're gonna shift your signal, you're gonna increase your phase margin. I mean, you're gonna decrease your, I forget already. You're gonna decrease your phase margin, such that soon you'll reach this point where you become unstable. So therefore, this low pass filter is not that good because it will cause phase shifting. And why do we want to shift the signal in the first place? Alright, if you still remember your RT, alright, is what? Your RT is an analog signal. An analog signal can be represented by many signals, alright? For example, if you want to create a square wave, alright, you have a square wave over here, okay? And then you have a multiple signal, very small signals all over here, alright? And then you have other color signal that somewhat eventually will help you to form your square wave over here lah, okay? So sometimes if you want to create a square wave, for some reason, I don't know, I just anyhow form one example. But because of this, because you want to form a square wave, you require some tuning. So you're going to shift your signal somewhere over here, or something like that. Alright, so therefore, in order to ensure that your so if you instead of over here, you shift it over here, okay? So you can extend the square wave to this portion. You see? So this is somewhat the shifting effect. Alright, so I repeat again, if some just anyhow form only, but it makes a bit sense. If I want a longer this thing over here, longer period of the square wave, what I can do is to implement a new one, and then a new one is over here, but if I want to shift, I need to shift it over here right? So if I were to shift it over here, I'll need to shift. So this shifting for low pass filter causes the system to be unstable. Alright, so therefore in order to shift certain stuff, instead of having this low pass filter, we're gonna use the 0th order hole. Alright, your 0th order hole. So this is where you can see all your square wave all coming up already. Okay, and this is the thing that we're going to talk about in the next video of why 0th order hole is better. But the trade-off is that you need to have a frequency that is 2 times your original one in order to prevent aliasing. For this case, low pass filter can straight away prevent aliasing with your current your sampling frequency, but you cannot shift the signal. And for you to take note is that for your low pass filter, alright, the equation for the S domain is equals to 2 over T over S plus 2T, or somewhat like a over S plus A. Okay, your low pass filter is of this equation. Alright, so maybe I should say that this is your transfer function for your low pass filter. Okay, this is A over S plus A, your transfer function for your low pass filter. Later on we will talk about it, but I'll just introduce you, and the meaning of how to derive this, I seriously don't know where it comes from. Alright, but take note that your A is 2 over T for don't know what reason. Okay, I seriously don't know. Okay, I think this is the frequency lah. Alright, because this is the period. Alright, it's equals to your frequency, because 1 over T is equals to your frequency. Alright, so if you were to switch, I think you someone see the meaning already, right? So I think this may be your frequency lah. Your A is your frequency. Whether is it your sampling frequency or whatever, seriously, I don't know. Alright, these are the little stuff that I don't know, but at least you gotta know how the low pass filter works and things like that. See you next video for 0th order hole.